And we'll first start off with the definition for the least common denominator. And the least common denominator is the factor or the factors that have the greatest amount of appearances in any one factorization. And this definition for the least common denominator will help us to add and subtract rational expressions, simplify complex fractions, and solve rational equations. So first we'll take a look at a real number example. 5, 6 plus 3 over 28. And the first thing we'll do is find the least common denominator. So I'll simply take my denominator 6 and 28, and I'll completely factor using prime factorization. So the prime factorization for 6 is 2 times 3. Prime factorization for 28 is 4 times 7. Which is 2 times 2 times 7. The least common denominator, based on this definition, we have 3 factors, some 2's, a 3, and a 7. The 2 appears once in the factorization for 6. It appears twice in the factorization for 28. And based on the definition, the greatest amount of time that our factor appears is twice. So I'll use it twice in the least common denominator. The factor 3 appears here once, it doesn't appear here at all. The greatest amount of time the factor 3 appears is once. There's also a factor of 7, which doesn't appear at all in the factorization for 6, but appears once in the factorization for 7. So our least common denominator is 84. So next we'll make equivalent fractions. And our denominator for 6 was multiplied by 14. I can take a look at my factors. The factorization for 6 is 2 times 3. The least common denominator contains a 2 and a 3, also the 2 and the 7. That's 14. Top is multiplied by 14. 5 times 14 is 70. The 28 was multiplied by 3. You take a look at the factorizations. So we multiply the top by 3. We have a common denominator, so we keep our common denominator. Combine our numerators for 79 over 84. In the next example, we have 5x over x plus 3 plus 28 over x minus 3 minus 90 over x squared minus 9. So once again, we'll find the least common denominator. So we'll factor all of our denominators. See, x plus 3 is already factored. X minus 3 is already factored. And x squared minus 9 is a sum and difference, and we factor that down to x plus 3, x minus 3. For our least common denominator, the x plus 3 factor appears once here. It doesn't appear here at all. It appears once here. The greatest amount of time that the factor appears is once in any one of these factorizations. So I'll only use it once in my least common denominator. The x minus 3 doesn't appear here at all. It appears once here. It appears once here. The greatest amount of time it appears in any one of these factorizations is once. So I will only include it once. So now we'll make equivalent fractions. And our first denominator was multiplied by x minus 3. So we'll multiply the numerator by that same quantity. We'll distribute, and we have 5x squared minus 15x. The x minus 3 denominator is multiplied by x plus 3 to get the least common denominator. So we multiply the numerator by that same quantity and we distribute. So we have 28x plus 84. And our x squared minus 9 was multiplied by 1 because it's exactly the same. So that fraction remains the same. So now we keep our common denominator and combine our numerators. We simplify. X squared, bring that down. Negative 15x plus 28x is a positive 13x. 84 minus 90 is a negative 6. We want to make sure that our rational expression is completely simplified. So we'll factor the top if possible. And we can factor the numerator down to 5x minus 2 times x plus 3. We can cancel common factors, so our final answer is 5x minus 2 over x minus 3. For our next example, we're given 4 over x plus 5 plus 4 over 7x plus 20 over x squared plus 5x. So we'll find the least common denominator. So we'll proceed to factor all of our denominators. X plus 5, it's already factored in the simplest form. 7 times x is just 7 times x. Here we can factor out the greatest common factor of x. And we're left with x plus 5 inside the set of parentheses. For our least common denominator, the 7 appears once. So we'll include it once. The greatest amount of time that the x appears by itself is once. So I'll only include it once. And the greatest amount of times the x plus 5 factor appears is once. So we have our least common denominator, 7x times the quantity x plus 5. So now we'll proceed to make equivalent fractions. And we can see from our first denominator, the x plus 5 was multiplied by 7x to obtain the least common denominator. So we'll multiply the numerator by 7x. 4 times 7x is 28x. The 7x was multiplied by x plus 5 to get our least common denominator. So we'll multiply the numerator by x plus 5. Our last denominator, x times x plus 5, is multiplied by 7 to get our least common denominator. So we'll multiply the numerator also by 7. Since we have a common denominator, we'll keep our common denominator. We'll combine our numerators. Next, we'll simplify. 28x plus 4x is 32x plus 160. Again, we want to make sure that our rational expression is in simplest form, so we'll proceed to factor the numerator if possible. There is the greatest common factor, 32, which leaves x plus 5 within the parentheses. Next, we can cancel common factors. And we have our result, 32 over 7x. And for our last example, dealing with rational expressions, b minus 2 over 7b plus 35 minus b plus 1 over 9b plus 45. So again, we'll find the least common denominator. We'll factor both of our given denominators. In this first factor, in the first denominator, the greatest common factor is 7. So I'll factor out a 7. In the second denominator, the greatest common factor is a 9. So we'll factor out a 9. For our least common denominator, the 7 only appears once. The 9 only appears once. The b plus 5, the greatest amount of time it appears is only once. So I'll only use it once. And we have the least common denominator, 63 times the quantity b plus 5. So now we'll make equivalent fractions. And our first denominator was multiplied by 9 to get our least common denominator. So we'll multiply the numerator by 9. The second denominator was multiplied by 7. So we'll multiply the numerator by 7. We have a common denominator, so we'll keep our common denominator. Combine the numerators. But here we want to be careful and distribute our negative. We'll simplify the numerator. 9b minus 7b is 2b. Negative 18 minus 7 is negative 25. And we have our simplified answer. So in our first example, we have 8 over x plus 3 over z all over 7x minus 5 over z. And once again, we'll find our least common denominator. So we'll factor all of our denominators We have an x, a z, another x, another z. So based on our definition, the least common denominator is xz. In simplifying the complex fraction, we'll multiply both the numerator and the denominator by the least common denominator, which is otherwise known as a special form of 1. So I'll distribute the least common denominator with every term in the top. I'll also distribute or multiply the least common denominator by every term in the denominator, and we'll simplify. So x over z times xz. Our x's will cancel, and we're left with 8z. 3 over z times xz. Our z's will cancel, and that leaves us 3x. In the denominator, 7 over x times xz, our x's will cancel, that leaves 7z. And finally, our z's will cancel, which leaves 5x for our simplified complex fraction.